Tornadoes can be one of the scariest aspects of thunderstorms, and yet at the same time, tornadoes have often been one of the most intriguing parts of meteorology. Many weather enthusiasts love to look at tornadoes, watch the tornadoes form, watch them happen. It's just an awesome sight to see these tornadoes forming and moving along. No, the destruction that they cause is not what's intriguing, but the tornado itself. What is a tornado? Well, it's just a rapidly rotating column of air that blows around a small area of intense low pressure with a circulation that reaches the ground. Basically, if you recall, we had a supercell thunderstorm, and we'll show you one of those in just a second, that has a rotating updraft. Well, that rotating updraft, that rotating column of air, forms a low pressure at its base, and as the low pressure gets stronger, the circulation gets stronger, and if the circulation gets stronger, you can form a tornado. So the basic requirements for a tornado are you have to have an intense thunderstorm. It doesn't have to be a supercell thunderstorm, but it's much more likely with a supercell thunderstorm. You need to have conditional instability, and you need strong vertical wind shear. So here's how it forms. You start off with wind shear. You have air that's moving in different directions or different speeds or both, and that causes the air to kind of roll up in between the two layers. So you've got this column of rotating air. And then atmospheric instability will start to lift one end of that rotation up, that column of air up, so that now instead of being a horizontally oriented column, it's now a vertically oriented column. And like we talked about before, these are perfect conditions for a supercell thunderstorm to form. That is why supercell tornadoes are much more likely than other tornadoes. So the updraft lifts that vortex from the wind shear up to that vertical position. You've got yourself the nice vertical updraft coming into your thunderstorm like so. Likewise, in a thunderstorm, you're going to have a region with a downdraft. You're not going to have any precipitation in the updraft region because the updraft is carrying all that precipitation upwards. Rather, all the precipitation is going to happen in a downdraft region. The reason I bring this up is if you are looking with a radar, what you'll see is a massive amount of precipitation in a region where you have a downdraft and no precipitation here where you have the updraft. And you end up with a radar signature that looks kind of like a hook. So we call this a hook echo. And whenever you see that on a radar, it is a strong indication of tornadic activity. Here is an actual radar image in Moore, Oklahoma. You'll recall a number of years ago they actually had a very strong tornado. This is the hook echo for that tornado. Here's the downdraft region of the tornado, and it forms a hook. There's your hook, and that's where your tornado formed, right there. Another way to indicate where tornadoes might be, and you can bet they use not only the hook echo from here, but they also use this method as well in combination with each other. They look at wind speeds. Now, whenever a radar sends out a signal and receives the echo back, not only does it measure where there's precipitation happening, but whether it's moving towards the radar or away from the radar. Generally, when you see green, that means it's moving towards a radar. I don't know where the radar is in this picture. We'll say it's here, somewhere down here. So you have green meaning it's moving towards, red meaning it's moving away. And then right here, you've got a strong change. You have winds moving away and winds moving toward, and it's sharp and sudden. There's no gradual transition like there is over here where you have towards and then away. but here it's a very sharp transition. That's a good indication of a tornado there as well. And so here you have your supercell thunderstorm, very often associated with mid-latitude cyclones. Don't have to be, but often are. Why? Because ahead of the cold front, you're going to have warm, moist air coming from the Gulf of Mexico near the surface, and cold, dry air moving from the Rocky Mountains behind the cold front. That creates an awful lot of wind shear and huge amounts of instability in that area that allow the supercell thunderstorm to form, and if it's strong enough, even a tornado. Now, around the tornado, you end up forming something called a wall cloud. Here's what happens with a wall cloud. As the low pressure at the base of a supercell thunderstorm intensifies, the saturation vapor pressure actually drops. And as the saturation vapor pressure drops, the relative humidity increases. So here at the top, if the pressure drops, relative humidity increases, you're going to start forming a cloud right around the base of the rotation. This is called a wall cloud. If the pressure drops further, that cloud is going to start extending lower and lower. Then if the low pressure intensifies enough, that cloud will actually drop all the way down to the ground. So yes, it is possible to have a tornado where you only see, say, up to, about there. That's what we would call a funnel cloud, but the air itself would still be rotating near the surface and you could still have damage even if it doesn't look like the tornado's on the ground. Because what you see is really nothing more than a cloud from the decrease in pressure. All right, let's shift gears a slight bit. Let's talk about tornadic winds. Where are the strongest winds in a tornado? First of all, we don't have weather sensors in a tornado. If you've seen the movie Twister, it was all about getting weather sensors into a tornado, which is all great and fancy, but it's not realistic. Something like that would cost a lot of money. It would depend on an insane amount of luck. It just wouldn't work very well. So we actually do our measurements of tornadic winds based on the amount of damage left behind after a storm, or we use the Doppler radar like I showed you a few slides ago. Now, here's what we found. We found that as a storm moves forward, the right side of the storm always tends to be the strongest. You may have heard the same story with hurricanes. Yes, for exactly the same reason. Let's say that you have a tornado that has winds of 100 knots. So the winds are spinning in a circle at 100 knots. Let's also say that the tornado is moving to the northeast at 50 knots. Well, then here on the right side of the storm, not only do you have your 100-knot forward motion of the winds, but you also have the 50-knot forward motion of the tornado. And so that adds up together to give you a total wind speed of 150 knots, much stronger winds on this side. Whereas on the left side of the storm, winds are going at 100 knots in this direction, so winds are going to the southwest, but there's the forward northeast motion of the storm that counters each other. So 100 knots to the southwest plus 50 knots to the northeast gives you a total of 50 knots to the southwest. Basically, the left side of the storm is going to be the slower side, and the right side would definitely be the stronger side. And sure enough, whenever you see a tornado, you can always tell the direction it moved, because this band on the right side of the storm will have very extensive damage, where on the left side of the storm, you would have minimal damage because of the decreased winds. So what constitutes strong winds? Well, some of the most powerful tornadoes have winds of about 220 knots. That's roughly 200 miles an hour. That's the strongest hurricane we have ever felt. That's one of the most powerful tornadoes that we've also felt. Usually we aren't up that high. Those are extreme circumstances. Most tornadoes have wind speeds of less than 125 knots. Now, sometimes you can actually get multiple tornadoes forming in the same storm. And if they're close enough to each other, they will form a much larger circulation pattern. And there we call it a multi-vortex tornado. These can be very nasty. You can also have a family of tornadoes or tornado outbreak, multiple tornadoes that come from the same storm system.